We're given a of x be equal to a naught plus a1x, so until a and x parent be a polynomial function with integer coefficients, where a value can only take values from 0 to less than 3. Okay, they already mentioned that it is integer coefficient such it. So that means what values AI can take? They only can belong to 0, 1 and 2 according to the statement. Okay.
Yes, sir.
And then they are given that a root 3 is giving them 20 plus 17 root 3. And which of the following is are true? Okay. So root 3 is coming. Okay, that's a good sign. That means maybe root 3 power 1 or root 3 cube or root 3 power 5 was being still done. No. I told you every time advanced is incomplete without the options. So look at the option. Option A was talking about its degree. Degree 4 it says. And option D says it's an odd function. See, polynomial, if you have to claim them as an odd function, that means you should only have the odd powers. You get my point?
Yes,
You
sir.
want to claim a polynomial as an odd function, you should have only odd powers. Okay. So if D is going to be true, then A cannot be true. So they are contradictory options. Okay. So
Yes,
the
sir.
odd function as a polynomial meaning you should have like only x cube term, x term, or x power 5 term, x cube term, x power 1 term, x power 7 term, x power 5 term, x cube term, x power 1 term, like that. Okay. And since root 3 is being allowed, we still see a good opportunity of it being true. Okay, let me try with this. So can it be just linear, Sachit? Is that possible?
No, sir, it's not possible.
It's not possible because of the coefficients. Because if you just take a linear, even forgetting odd function, if you just take a linear, it should look like a naught plus a1x. And they are talking about a root 3 being 20 plus 17 root 3. So you will have x being root 3 here. A1 root 3 plus a naught will turn up. And if you are comparing to 20 plus 17 root 3, so, and a naught is an integer as you know, a1 root 3 and 17 root 3 will be on comparison. A1 will become 17, but they clearly said AI cannot take values more than 2. 0, 1, 2 are the possibilities. So this is a wrong scenario. If you next go cubic, okay, if you go cubic, and like say me having a naught, a1x, a2x square, a3x cube. I'm going to the cubic and root 3 when I apply, substituting x equal to root 3, I'll get this will become 3 root 3, a3 times 3 root 3. This will become 3 a2 and this will become root 3 a1 and plus a naught. So go cubic. All right. So I do
Yes, sir.
understand like then this these two will be rational terms because a naught and a2 and all will be integers and these two will be the irrational terms. And I have to compare that to 17 root 3. So that tells you indirectly that a1 plus a3 has to be equal to 17. But is that possible? Because AI values can maximum only be till 2.
It's not possible again, sir.
It's not possible to be stopping there, right? So 17 is a big call. So what I understand from that is like its degree has to be a little higher more than what we want. So even option A is talking about degree being 4. 4 is still a small number, I should say, no? A naught, A1x, A2x square, A3x cube, A power 4, x power 4. Even if you go there, and this will be your irrational terms, and same scenario will be stopping, then you will still have a1 root 3 plus 3 root 3 into a3. Do you understand what's happening? But here, one
Yes, sir.
second. When I was comparing this, I took root 3 common. I forgot to put 3 here. Okay. A1 plus 3, A3 can it be 17? I wanted to check, but still not be possible for that. Correct? Because maximum value itself will reach till 6 plus 2, 8 only. It cannot reach 17. Understood? So even if I put degree 4, this cannot be possible, right, Sachit? So option A is wrong, no?
Yes, sir. Option A is wrong, sir.
Option A is wrong because the same issue will be happening because your irrational term, which is a1x plus a3x cube, when you compare the coefficient to 17 root 3, so you will still find a1 plus 3a3 equal to 17, which is not possible to be achieved. Okay.
Sir,
So, but
X is equal, if the degree is 5, it is working, sir.
yes, so we'll take degree till 5. So a5 x bar 5. So because we need support, I told you, we are not able to reach 17, that's still big. So now when you put root 3 in this place, so you'll have a naught plus root 3 a1, 3a2, 3 root 3 a3 plus root 3 square, no, 9a4 plus then this is going to be 9 root 3 a5. So this seems possible to achieve, right? Yeah. So a5. So then if I add all the root 3 terms coefficient, I'll be getting a1 plus 3a3 plus 9a5 becoming equal to 17. This seems manageable to be achieved. I can keep a5 to be 1. I can give a5 to be 1, so that's giving me 9. And I can keep a3 to be
2,
2.
sir.
So 9 plus 6, 15 will come and this can be kept 2. Okay. 9 plus 6, 15 plus 2. So we have to ensure that the other coefficient, 20 plus 17 root 3, no, it was totally. Whether 20 is being achieved
Yes,
as
sir.
well. That's what we need to check. So for that, I'll take a naught, 3a2 plus 9a4 to check for 20's occurrence. So for this to be achieved, so if I keep 2 here, 9 2s are 18 and 2 here, that is enough, no?
Yes, sir. A2 is 0, sir.
18 plus 2 is 20, that is matchable. Or if you reduce it by 1, I mean, keeping A4 as 1, 9, and 2 also, 3 2s are 6, 15. 15, and this is not possible. Okay, or if 2 here and 2 here, if you keep like, that is not possible either. Yeah, so that means this is the only combo that we are getting it right. So if you rearrange it, so 2 plus, okay, 2 plus A1 value we got to be 2. So 2x plus A2 x square. A2 value we got it to be 0. We are trying to put it 0. And then A3 value we got it to be 2. So 2x cube. Okay. And A4 value we got it to be 2. So 2x power 4. A5 value we got it to be 1. 1x power 5. So this is the polynomial we are getting. Correct. And it's an odd degree polynomial. Okay. It's an odd degree polynomial, but not an odd function. Why it's not an odd function? Because you still have a even powered x term here. And also you have a constant x power 0 term. If those two terms were not present, I could have happily called it as an odd function directly. Okay, next, if any odd degree polynomial, people remember that any odd degree polynomial is a polynomial which ranges from minus infinity to
Minus infinity
plus
to infinity.
infinity. So that means it's subjective only. Mentioning A giving R to R, yes, it's subjective. So C is right. Then finally check whether A2 is 86 or not. That's all.
Correct, sir.
Yes, sir, it is 86.
Yeah. If this is your A of X, A2 is coming 86. So then B is also right. So every year they generally come up with giving at least one theory of equation based question, like a polynomial based question, playing a degree. So this question eventually has some deep roots with, what to say, like Olympiad style, because we have to come up with some manipulations to reach this point. Okay. If you're done, we'll just to the next question. Dia, So in advanced level, like you can try to start with a higher degree directly.